I've kicked Mark out of the studio to start a new multi-part mini-series where we go back to basics on all the things that make up a home solar and battery installation. There's no silly questions, so leave some comments down below as we dive into the brains and the gearbox of the solar array, the inverter. So what on earth is an inverter? In really simple terms, an inverter is a device that converts DC power or direct current into AC power or alternating current. And what is the difference between DC and AC power? So DC power is like a constant stream, a bit like water through a hose where it all moves constantly in one direction. Whereas AC power or alternating current is a push-pull type of power, almost a bit like a piston in an engine that's moving backwards and forwards, or often described as a wave. Now, when you get power from the street, so out of your power points, this is an alternating current, whereas the panels are producing direct current, and we need to convert that power from that form that comes from the panels, DC, and we need to synchronize with that wave form of power coming from the grid. And that is the primary job of the inverter. It does a bunch of other things as well, like, maybe connects to a battery, or it might show you what you're producing and consuming, but the primary function is it converts it into a usable form that we can use in the house and feed into the grid. You might have heard that there's a few different types of inverters, but the primary two types of inverter are a string inverter or a microinverter. Now, the phonies that I showed before is a string inverter where all the panels are connected in series. So we're almost like fairy lights. They're connected positive, negative, all in one big row. And you have one inverter for the whole solar array. Another form of inverter is something like a microinverter. So, for example, Enphase is an example of a microinverter. And the difference between a string inverter, we have one big inverter for the whole array, is a microinverter. Every single panel has its own little inverter doing that DC to AC conversion. Now you might say, well, which one's best? Well, realistically speaking, most systems installed in Australia are string inverters. These might include things like Fronius, Sungrow, Sig Energy. Microinverters are a little bit less common. They used to be more common, but when we're talking batteries now, generally speaking, a string inverter is a much simpler solution. Speaking about batteries, well, what is the difference between a normal or non-hybrid inverter and a hybrid inverter? And that's a really good question, all right? So, look, older systems were just what we would call just a standard grid-connected inverter. And their job was, again, just to convert power from DC and push it into the house as AC power. Now, modern inverters, especially if you're starting to think about batteries for your home, need to do a lot more. It needs to also control a battery. And this is what a hybrid inverter does. It's a hybrid between a solar inverter and a battery inverter. And this is what we're often installing today because batteries are the future. But it's not to say that you can't install a non-hybrid, but it's becoming less common and usually less advised because at the end of the day, while you might not be ready to get a battery now, it is something that you might want to get in the future. So regardless of if you're going to get a string inverter or a microinverter, a hybrid or a non-hybrid, one of the most common questions you'll get asked when you start looking at solar is, do you have single phase or three phase to your house? Now, most homes in Australia, especially if they're a smaller home, will be a single phase connection. And the best way to think about single phase is it's one AC wave coming in, whereas three phase, you'll have three AC waves coming in. And there's sort of a few ways you can tell if you've got single phase or three phase. But from the really simple standpoint, so when we've got a connection to the grid, we've got three cables. We've got the active, we've got the neutral, and we've got the earth. So this is where the AC wave comes in. Now on three phase, which we have in this bigger cable here, what we have is three active cables. So each one of these actives has its own AC wave, and these AC waves are phase shifted from each other. So you can sort of think about it as like three pistons on an engine instead of one piston on an engine. And the reason some homes will have three phase is either because they have high power loads, or they might have a big ducted aircon where they have a big motor. So often for electric motors, three phase is much more efficient. Again, it's like having three cylinders on an engine. So on a three-phase connection, instead of three cables, we've got three actives, one neutral, and one earth. So 5 cables. So it's a much heavier duty connection. So as a homeowner, unless you're a Sparky, you should not be opening up your switchboard to find out if you've got 5 cables or 3 cables coming in from the street. That's not the way to do it. So if, as a homeowner, or if you're not a Sparky, how do you find out if your house is single phase or three phase? A really good place to start is having a look at your main switch. So this is your circuit breaker, which will turn off the whole home. A single phase house will be a single pole. It'll look something like this in most modern homes. Now on three phase, because you've got 3 active cables coming in, you need basically 3 of the single phase units. So see how this is 3 times the size. Now, if you've got a big switch like this, you've almost certainly got 3 phase. If you've got it on an aircon, you've almost certainly got 3 phase. Otherwise, if you only see ones like this, you've basically got single phase. Now, another way you can tell if you've got single phase or 3 phase is you can have a look at isolation links. So most new switchboards and meter boxes will have these isolation links. And it's a way for Energex or a fireman to turn off the power to your house in an emergency without having to get up on the pole and pull the pole fuse. Now, on 3 phase, you'll have 3, again, 1 for each active cable. On single phase, you'll only have 1. So again, this is a very easy way to check when you open up your meter box how many phases you have. Some homes, you might have 2. Now we call that 2 phase, but we'll talk about that in another video. So one of the most common questions I get is, where should I put my inverter? And you think, well, this is the most complex part of the solar system. It's doing all this conversion and feeding power into the grid, or maybe controlling a battery. We should keep this inverter cool. And that's to keep the inverter lasting as long as possible. The cooler we can keep those power electronics, the longer the inverter should hopefully last. So the first thing we want to do is put the inverter in a cool location, like a south-facing wall or in the garage. We definitely want to keep it off the northern side or the western side where it's going to get cooked in the midday sun. But the other thing we want to do is keep the inverter close to the switchboard if it's possible to do so. This does reduce the cabling costs, and so it's partly a cost thing. But if we have really long cables from the inverter all the way to the switchboard, we can get this phenomenon called voltage drop, where there is the losses in that cable. Basically, the resistance in that cable are eating away at some of your power. So you have to use much thicker cables, which can push up costs. But sometimes your inverters can actually ramp down if there's too much of a voltage drop across that cable. So we don't want that from happening. So the best place to put the inverter is ideally in a cool location right next to the switchboard. So a garage, ideally. Now, let's say you can't put the inverter in a cool location, or we can't put it right next to the switchboard. Well, you can have it further away. We can put covers over them to give them some protection. The other thing that might come into play is, let's say there's no suitable place to put a battery, and we'll go into batteries in another video. But sometimes we have to have the inverter further away from the switchboard because we need it near the batteries as well. So this is really where talking to a consultant can give you the best idea as to where to put this. But again, close to the switchboard in a cool location is usually the best place. Now, another common question I get is, how does the inverter know where to send my power? Will I see the lights flicker when it switches from solar to grid, and when the sun sets? And the answer is, it's a fluid system. So essentially what happens with the solar power, you can think of it a bit like water again. So you can think about it as having a pump, or like it's pushing water into the house. So you can think of that as your solar system. You can think of that you might have all these little taps, which are your power outlets. And then you have the grid, which is a big dam up the top of the hill. So it's going to first push power into your power points, all your appliances, and then anything that's left over or any excess is going to have to go somewhere. So this gets pushed into the grid. Also, the pressure rises, or the voltage rises of the inverter, and it pushes it out into the street. So there's no switching inside that inverter saying, okay, send power to the fridge, send it to the hot water, send it to the grid. It's a fluid system. Now, if you have a battery, there is some extra control. The inverter is going to have to decide, okay, how much to send to the battery, how much to send to the house, and what to do with that power. So we'll have some level of consumption monitoring, so the inverter knows how much power is going to the house and what's going to and from the grid, and it can calculate this. Talking about consumption monitoring, how can I know that my solar system's working well? How do I know if I'm using the power effectively? Well, one of the things that we can add with a inverter, and pretty much is done with all systems today, is we add a consumption meter, which measures the power that goes to and from the grid. So the inverter knows what it's producing, it knows what's going to and from the grid, and the difference between those two amounts, it can calculate how much power you're using inside the house, either to control a battery or just to tell you, hey, you're using your power from the solar, or you're using it from the grid, and how much is coming in and out. It's a really important information. And so all inverters now come with apps. It's very rare to have an inverter that doesn't have Wi-Fi connectivity. Every modern system has that these days. It's a standard feature. And there's usually an app that comes with your inverter. So regardless of the brand, you're almost guaranteed to have production and consumption monitoring as part of your installation. Just to go through just a quick example of a production and consumption graph. So I've brought up a system here without a battery, and on a nice sunny day, you get this really beautiful bell curve of what the solar has produced throughout the day. So as the sun rises, the system produces more, and then as the sun sets, it starts to produce less. And then there's a squiggly line which shows you what you're using throughout the day. So in this particular graph, everything in yellow has come directly from the solar, everything in grey has gone to the grid, and then everything outside of that curve is coming from the grid at night. Now, I can show you an example with the battery, and now we have a green overlay where everything in green is going to the battery, everything in grey is still going to the grid, everything in yellow is used from the solar, and then at night, if we highlight the consumption, everything in green is coming from the battery at night. So they're much more self-sufficient. Maybe there's a little bit coming in and out from the grid once the battery is discharged, and that's normal. Another really common question I get asked is, okay, I don't have a battery, but I've got solar, so surely if I have a blackout and the sun is shining, I've got power. Well, the reality is that these are grid-connected systems, and so if there's a blackout, maybe it's because there's a power line down or somebody's doing work on a line, these systems have to turn off. So if you don't have a battery, you won't have power even though you have solar and the sun is shining. Okay, but if you have a battery, well, then you might have backup circuit capability, and this will become down to what your inverter has been set up with as part of that installation. But it's not a guarantee, so you have to make sure when you get your battery installed that this will be part of it. But we'll go into batteries again in a different video. Another really common question we get asked all the time is, how do I future-proof my system? So look, maybe right now you're deciding that, okay, well, I want to get the solar and I want it to be future-proof for a battery and I want it to be future-proof for when I get an EV. And how do I make sure that it's ready for all these eventualities? But I'm just not ready to invest in it all right now. And that's a great question. The best thing you can do to future-proof yourself is to get the inverter and the solar array that is going to see you into the future. It's really hard to add panels on at a later date, and sometimes you have to upgrade the inverter or even add a second inverter to do this. So my best advice is get the hybrid inverter if you're going to get a battery in the future. Get the bigger inverter with the bigger array now if you can afford it, because that in the long term will make you much more future-proof for if you add a battery or if you get an electric car. Okay, and that will allow you to integrate all of that together. If I'm not quite ready to get a battery now, should I buy a non-hybrid? Because the hybrid inverter is only there for if I get a battery. And I would say, well, if you're thinking about a battery even in 3 or 5 years' time, get the hybrid inverter now. It makes adding a battery down the track much cheaper because you're not going to have to replace the inverter, and it makes it much more future-proof as well. So again, it's one of those things is the best way to choose your system or choose your inverter is to think, what might I need in 3 or 5 years down the track? Now, if it's something that you never foresee, maybe you can save yourself a little bit of money, but I don't think that's the way to go. If you're really unsure, well, maybe Fronius Gen 24 is a great option. There are some inverters on the market which have all the hardware there ready for a battery, or basically are a hybrid inverter, but then they're software locked, and so you can add that battery functionality if and when you make that upgrade later down the track. All right, so that was a collection of very common questions I get as a consultant when it comes to inverters. Now, I can't think of every question that you might have off the top of my head. So if I've missed anything or you think there's something that I should have mentioned, please leave me a comment down below and I'll do my best to get onto it straight away. Now, in the next episode, we're going to dive into panels and how they're installed up on a roof, which is the next big component of a solar installation. So click the like icon, hit the bell, and subscribe for the next video.